welcome back to AGT STEM. Today we're going to be watching a video about erbium. So, without further ado, let's hop to it.
Lovely.
I've just realized that erbium is the most crucial element for the internet of all the elements on the periodic table. And so I want to take you across to materials engineering, where we can see a demonstration which will explain to you why it's so important and why without erbium, many of you couldn't be watching this video.
Erbium is another lanthanide metal. It's soft, silvery, quite malleable, very reactive towards oxygen and water. And I suppose for us right now it's quite significant because it was originally discovered from a mineral which was found in this quarry. So we're in a quarry in Sweden near Stockholm called Ytterby mine, and some black minerals that were found in this quarry actually were the birthplace for 4 new chemical elements, and erbium was one of them.
Erbium is a photographic filter, and it is actually a nuclear poison. What that means is that it will kill dead any nuclear fission process. So it's obviously got some applications there. It's an interesting element. When you make compounds of it and dissolve it in solution, it's often pink.
So this is some erbium trichloride.
Erbium is pink. It's one of the best colors out there. Pink.
You'll notice it's very slightly pink. I think this is one of the ones which, because of its pink coloration, gets used in jewellery and things like sunglasses and things like that, if memory serves.
More recently, erbium is used as an amplifier of light as it's transmitted down optical fibres.
So the reason we're here, and I'm all dressed up, these are the fibres that are used to transmit the signals for the internet. Now the reason they use fibres is because copper cables, which you would normally use for electrical signals, cannot carry nearly as much information, as many YouTube viewings at once, as one of these fibres. And the fibre is very strong. Neither Brady nor I have managed to break it. And the problem is that even with this fibre, with a light beam going down it, eventually the light gets weaker and weaker and you lose the signal. So every 50 kilometres, every 30 miles or so down the fibre, when it's under the sea, you have to amplify the signal to get it back up again so that our YouTube video can reach the other side of the Atlantic or to India or wherever. And so the way you've got to do it, you've somehow got to amplify the light, make it more intense. And you can do this with erbium, because if you put erbium into the glass, then if you shine a light onto the erbium atoms, they get excited. And then as the light comes in from the signal, it interacts with the erbium atom, and the erbium atom loses its energy and gives out more light. So essentially the light comes in and comes out twice as intense. It then keeps going another 30 miles and you repeat it. Here that we've got the infrared laser. I used to work with lasers, but I've rather given up now. So it's quite nostalgic. And is it switched on? And if you put this in the laser beam, you can see there's a special screen here which will actually take an infrared laser beam, which you can't see, and make it into visible light so you can see it. We've got infrared light going into a piece of glass with erbium in it. Now, what is happening here is the physics here is slightly different from what happens in the amplifier, but is really quite fun because a light beam that you can't see is suddenly being changed into visible light, into green light, which you can. Yes, it's very important. I had heard about it in lectures, but when we videoed our first video about erbium, I'd completely forgotten about this, although without it, nobody would have seen any of our videos.
Welders, people that join pieces of metal together using either large electric fields or extreme temperatures, have special masks to protect their eyes from the very bright light which is given out in the welding process. Welding goggles typically can include erbium salts because they're very intense and they absorb a massive amount of the light so that the eyes of the welder are not damaged at all.
So under the sea, you have these fibers with copper wires going next to it, carrying the current for the diodes that excite the amplifiers all the way along. And apparently, the current going down these wires is quite attractive to sharks. And so in shallow water, sharks come along and see the cable, and it seems attractive, and they start chewing it. And although Brady and I can't break the fibers, a shark in full spate can easily cut through it. And so there have been quite a lot of problems with the optic fibers in shallow water being chewed to bits by sharks.
I didn't think that a shark would want to eat a cable, but apparently they do. Thank you so much for watching, and we'll see you next time. Stay smart. Bye!